Alright, so we're making good progress. We know about interfaces, type aliases, classes, and how they can all kind of work together. Now there's still one big major topic I want to cover, and that's something called generics. So in simple terms, generics give us a way to make generic or reusable structures, whether they be functions, interfaces, or classes, that can be then used by many different data types. And they allow us to do this by giving us a way to pass the data types themselves into those structures, almost like arguments. Now, I'm quite aware that that explanation alone probably won't give you that light bulb moment, so to aid me in this discussion, I prepared a couple of examples. So, imagine we have three functions called log and return string, log and return number, and log and return boolean. Each one of those takes in an argument of a different type, a string, a number, and then a boolean. And inside each one we do the same thing, we log the value, and then we just return it. So in each case, we return the same type as we pass in, as an argument, a string, a number, and a boolean. Now then, if I invoke one of these functions and store the return value in a constant, for example the number one, and pass in any old number, then TypeScript is gonna know that the return value will be of type number because we specified that in the function, right? The same would be true for the string one and the boolean one. TypeScript would know the return type, which is good. The bad thing about this is that we've had to write out three separate functions which essentially do the same thing, just because for each one, we do it with a different type of data. And if we wanted to add more types, we'd be making more functions for those additional types. So it's not an ideal approach. Now you might be thinking, well, this sounds like a good time to pull out the any type, because if I use the any type as the argument type, and use any as the return type as well, then we only ever need one function to work with any type of data, and yeah, that's true. But remember, when we use the any type, it comes with a cost. And the cost in this case is that TypeScript wouldn't know the type stored in the return value. So let me demo that first of all. So I'm going to create now a new function. So function, and it's going to be called log and return value. Okay. Now it's going to take in a value, much like the ones above, only this time the type is any, and the type it returns is also any. So all we're going to do is console.log val, and then we're going to return the val as well. Now what I'm going to do is come down here below this and say const result is equal to log and return value, and then we'll pass in a string to say hello or something like that. And if we hover over result, we see any. So this is not ideal really, because when we use any, remember, we're stripping out a lot of the benefits of TypeScript. So if the any type doesn't help us, what can we do that allows us to make just a single function that can be reused by different types, and whereby TypeScript knows about what type is being used in the function when we invoke it, and also what type is being returned? Well, the answer is to make something called a generic function, which allows us to pass type information into it when we invoke it. So let's do a little example to demonstrate this. So this function that specifies the any type, I'm going to change into a generic function. And the way we do that is by adding angle brackets before the parentheses and then saying t. Now t stands for type, and it represents the data type we end up passing into this function when we invoke it. You don't have to call it t. You can call it bananas if you wish, but I would advise against it. T is a common convention that most TypeScript developers stick to. Anyway, the next thing we need to do is say that the type of argument will also be t. And this has to match what you call the thing in the angle bracket. So if you called it x, then this has to be x. We called it t, so this has to be t. So when we come to invoke this function, we can now pass in a data type as we invoke it. For example, I could say const result1 is equal to log and return value. And we're going to invoke that function. And now we need to pass two things to this function. The type inside angle brackets, and then the value argument, which must be of that type. So open angle brackets before the parentheses, and we'll say string as the type. And then as an argument, we need it to be some kind of string value. So I'm just going to pass in Mario. So now in the function, it captures the type, and it knows the argument will be of that type as well. And it's going to be a string in this case. we can now also specify the return type to be T as well. So when we return this value now, it knows it's of type T, which matches the type which was passed into the function in the angle brackets. So in the case down here, when we invoke the function, at this point TypeScript knows that the return type will be a string now. And if we hover over the result, we can see the type of string, which is awesome. Alright, so let's do another example. So I'm going to come down here, and in fact, I'm just going to duplicate this and say result. To this time is equal to log and return value. This time we'll say number. And when we do that, you can see we get an error right here because we expect the value type to be the same as the type we're passing right here. So we're getting an error. This has to be a number. So let's get rid of the string if we can. And instead we'll pass in a number, which is 25. And now TypeScript knows at this point that the return value is the same as this one because we say T and T, right? So they're the same. So now when we hover over this, we can see the return type is number. Awesome. Alright, now let's do another example, a tiny bit more complex. So I'm going to make a new function, and I'm going to call that getRandomArrayValue. And we're going to make this a generic function by using angle brackets. And same, we can pass a type into it, which again we call T. After that, we need parentheses. And we're going to take in an argument called values, which this time will be an array. Now, when we have an array type, we need to say what type of data is going to be in the array before the square brackets. It could be string, number, boolean, etc. But in this case, we're going to say T. So whatever type we pass into this function to capture, we're saying the argument is an array of that type. Now, as a return type, we'll say T, because we're going to return a single random element from this array, and we know that the elements inside the array are all of type T, okay? So then, first of all, we need to select a random index for this array, and the way we can do that is by saying const I is equal to math.floor first of all, then parentheses, and then in those parentheses we can say math.random, and multiply that by values.length. So this is going to get us a random index, which won't ever be higher than the length of the array that we pass in, right? Now all we need to do is return values, which is the array, then square brackets, and pass in I, which is the random index. And that returns us an item from the array, which we know will have the type T. And we specified the return type T right here. And also when we invoke the function, we're going to pass in what type it is. So TypeScript is going to note the type that's returned to us. So let's try this out. So I'm going to create a custom type using an interface. So let's say interface, and we'll call it user. Now this user is going to have a name property, which will be a string. And also it's going to have a score property, which will be a number. Okay, so now I want to create an array of user objects. So I will say const users is going to be a user array. I'm going to set that equal to an array, and I'm just going to paste in some objects right here. So we have 4 in total, each with a name, which is a string, and a score, which is a number. So we have that array of user objects. And now I want to pass this as an argument into this generic function, where user is T in this case. So let's try this. I'm going to say const random user is equal to get random array value, and then we're going to pass in the users. But before we do that, let's use our angle brackets. And I'm going to see right here that it's a user type that we're passing in. So now T is user. So the argument type needs to be used as well. So we'll pass in users. The argument type is an array of user objects, by the way, not just a single one. And now if we hover over random user, we know that we get a type of user back because we specified we return T right here. So the type we pass in is the type we return. Okay, so I'm just going to log the random user to the console.log, and then random user length. So press save, and then let's open up the terminal and see if this works. Yeah, we see this user right here, name Wario, score 75. Awesome.